So today we are going to see 323 number of connected components in the undirected graph, and we'll see in the deep drive session, and we'll continue to see how many approaches we'll do this 323 lead code question, and we'll try to solve by our best complexity and time complexity. Okay, so if we'll talk about today about this question, this is 323 of the lead code questions, and here is the statement. So you can see that we have given you have a graph of n nodes, and you are given an integer n and an array ss, where ss of I is a of I and b of I. So two nodes are connected with this ss, right? Node A and node B. So that indicates that an A is between A and B in the graph. Okay. Now what we have to do, we have to return the number of connected component in the graph. How many component we have, so it will return. So let's see this one, example 1, number of component we have to find. So as you can see that how we will find number of connected component, right? So this is very important questions, and I think that most of the questions these days are coming on uh, creating a component, right? So let's understand this question. So as you can see that we have given input n equal to 5 and ages is 1 0 1 1 2 3 4 and like that, right? So the first is given 0 and 1, correct? So what we have to do, we have to take two node 0 and 1. So these 0 node and this 1 node, right? So there is an edge, right? So we will connect this one, right? There is another edge is given what? 1 comma 2, right? This is given. So what we have to do, 1 is already here, so we do not need to write again. So we will write 2 here, but this is connected, 1 and 2 is connected, so we will connect to this one. Now another is given 3 and 4. So what we will do, we will two node we will take 3 and 4, right? So 3 and 4, none of them are connected with this existing component, right? So what we will do, we will connect each other and we'll say that there is two component. One is this one component, another is this one, right? Because these are not connected. So this is connected with itself, 0 1 and 2, and 3 4 is connected with itself, right? So number of, if we'll count, there is two component. So if we'll talk about this example, right? So in this example, see the ages given, right? So first, what ages we have given? We have given 0 comma 1. So what we will do, we will take 0 and 1, right? So both we will connect it, right? That we will do it. Now we have 1 and 2, right? So we will take 1 and 2. So what we will do, 1 is already there, we will take 2 here and we will connect 1 and 2, correct? Now what we have 2 3, right? Now we have edge 2 and 3. So we will take a 3, right, here, and we will connect with 2, right? Now what we have, 3 and 4. So we'll take 3 and 4. So what we will do, we will take a 4 here and we will connect with this, right? That's why this is the graph we have. So how many connected component we have? This is the only one component we have, and that's why it is returning 1, right? So I think you have understood this question, right? So what we will do, there is other approaches, right? Well, first we will go through the DFS approach, right? So when we want to traverse, right, nodes, right? So first approach we have in the mind is DFS. And if you're not aware with the DFS, right, you can check out on Google and you'll say DFS algo. They will give you little examples, right? Or either I'll create one video on the deep drive session and then I'll put here. So in an undirected graph, a connected component is a subgraph, right? So if we come to here, right? So this is undirected graph, right? There is two component, this component and this component, right? So in the undirected graph, a connected component is a subgraph, right? So both are called subgraph, either this one or this one, right? Both of them are what? Subgraph. This is subgraph, this is also subgraph. So each pair of vertices is a connected via a path, right? So either we'll say about this one 0 and 1, either this one. So these are connected with edges, right? Given edge, we have given a path, right? So essentially all the vertices in a connected component are reachable from one another, right? So if we'll talk about this one, right? So it is connected with each other, right? And uh, let's see this one, right? So let's consider this example, right? So what we have here, we have 0 1 and 2, right? We have taken 0 1 and 2, right? Three nodes are there and they are connected with each other, right? Another one we have 3 4 like this, right? So we have 3 and 4, correct? And another is what? 5 4 7 6, as you, if you can see here, right? So this one, right? What we have? We have 0 1 2. Now what we have? 3 4 we have, and 5 6 7 8 we have, right? So we can use DFS to solve the problem. If we run DFS starting from a particular vertex, it will continue to visit the vertices depth wise until there are no adjacent vertices left to visit. Thus it will visit all the vertices within the connected component and that contain the starting vertex. So each time we finish exploring a connected component, so we can find another vertex that has not been visited yet, right? So we will start a new DFS from there, right? And the number of times we start a new DFS will be the number of connected component, right? So that's why I have taken this example. So let's see, we have 0 1 2, right? Now we have 3 4, now we have 5 6 7 8, right? So here how many component we have, right? So let's suppose we have 0 component here, right? We have 0 component. Initially we will consider this example, so we are saying DFS. Now what we will do, we will vertex 0 is not visited yet, right? And that's why we have not counted. So we will perform DFS on it and will increment counting variable by 1, correct? How we'll do that? We will start with 0, then we will go to its all the connected variables, right? As connected nodes. So first it is connected with what? 0. I'll take here 0 1 and 2, right? So it is connected like this. So if we'll talk about this one, so this is a complete component, right? It is connected with each other, and that's why if we'll talk about the number of components, so we have what? 1. Now we will reach to 3, right? There is no edges between them, so we will reach to 3. We'll check the we will visit to 3 and we'll start going to 4, right? Because 3 is not visited, and so we have to perform on DFS on this one, and we will increment the counting variable by 1. So this is, now we have 3 and 4 this time, correct? So this is, we have started visiting from here and we have gone till 4. So this is one component, right? So one component was this one and now this one. So total component is what? 2 we have. Now we have vertex 5 and which is not visited, right? So if you'll perform on DFS on it, then it will increment counting by variable 1. Why? Because we have 5. We will go to 5 from, we will go to 6. 6 will go to what? 8. 8 will go to what? 7. And 7 will go to 6. So this is complete a new component. So now 3. That's why we have 3 component, right? Understood, right? So if we'll talk about, if we have to write algorithm, right? How we'll do that? So first of all, if we'll talk about algo, right? What we will do? we will create a adjacency list. Let's suppose we have adj. Will create will puts up all the vertices. First we should always create what? Adjacency list, right? And then what we will do, we will initialize uh, the vertices of this one, right? So what we can say, we will create an adjacency list such that it contains what? All the vertices of v, right? So like we have, right, like we have 5 what 6 7 and 8, right? Like this, these were here. I'm giving just an example. The last component we have this one, right? So if you'll talk about 5 is a vertices, right? So what is its neighbor, right? So vertices of this one can be 6, right? Can be 8, right? Like this. So it will contain all its adjacency list, okay? All the vertices of v we have. Similarly, what we will do, we will take we will initialize hash map or array, and we'll say that this is a visited list, right? So we'll take a visited, either we'll take what? This can be a map, hash map we'll say, and other can be a array. We can also take array. So two things is, either we'll create a map for visited and other is this one, and we will, why will to choose this? To track the visited vertices, right? You can say to track the visited vertices will take. In the third approach, what we will do, in third step, what we should find, we'll take a counter and we'll say that it is 0, number component, right? Take counter and initialize 0, and this is what? Number of component. It will give number of component, right? And in the fourth step, what should we do? We will iterate over each edges, right? We will iterate iterate over what? Each vertex. Iterate over each vertex, right? We will iterate over each vertex in edges that we have given, right? And if the vertex is not already in visited, start DFS, right? Then what we will check? We'll check if not visited vertex, right, is not visited, then what we will do? We'll do DFS, right? And then what we will do? Add every vertex during DFS to visited, and here we will do add every vertex, we can say every vertex in visited if we are doing this one, right? After DFS we will do, right? After DFS we will do. Now we will maintain our visited, right? This visited that we have taken, we will do here, right? Now what we should do, for every time a new DFS start, then we will increment the counter, right? So what we will do, every time we are doing DFS, so same way we will do counter plus plus, correct? And then we can say at the end we will return the counter, right? This is number of component, return counter, right? Very easy steps we have, only 5 steps we have and we have to follow, okay? So I think there is no issue on doing that. So I'll recommend you will pause this and try by your own, right? And if you are facing any issue, right? So let's continue the on the browser, the lead code browser. So let's understand here. So we have given what? We have given a count component function in which we have given number of nodes and all the edges we have given, right? So what we should do here, we will take initial variables, right? And that we can say a component, right? And that is our counter. You can say counter or component. So I'll say this is our component, right? Now components, right? Or number of components you also say. So I'll take number of components, and initially number of components what we have, we have 0, correct? Because I told you to create one counter at least, right? So this is our counter. Now what we will do here, we will have the edges, right? And how many nodes we have? N nodes we have, and so we have to track our node, right? So what we will do, we will take a visited, right? I told you to create visited. So visited, either we will take a hash map or we will take a array. So I'll take this one as an array only, and we can say new int, and the size is what? N, right? Whatever the size we have, that will come here as a visited array, right? And this is for track the node, right? We'll do tracking of node if visited, right? That we will do here. Now what we have, now what we should do, we will have our we have to create one adjacency list also, right? That is our first priority, right? I told you. So either we'll create from here or we'll create here. That's okay. We'll create the next step. Now what we have, to create adjacency list, and that list can be what? A integer type, right? So we'll take integer, right? And this integer is what? A list. So list of, we can say array, right? This is a list. List should be in the array, right? Because it will contain a many list, right? So this is our adjacency list, right? And we can say adjacency list. Okay, you'll see the adjacency. Yeah, it's fine. Yeah, adjacency list you also take. So this function, sorry, this variable will store the array list, right? And this is our what, we can take a size of n, that I'm taking actually. Now I'm taking in the form of array, right? Now we have taken what? We have taken in the form of array. We have taken what? Array list, and this array list we have to initialize it, right? So how we will do that? How we'll do that? We will take a variable for, and we'll say that we'll start with I equal to 0 for we'll start I equal to 0 first node, and then we'll go to the last node. So this is the things we have, and then I plus values, we can say we'll traverse all the its node. And for the adjacency list, we will add what? At its all the index, right? All in index. What we have a list of all each we can say each node will have a list of adjacency, right? And that's why we will taking adjacency list of I. We have what? Array of integers, right? What we have, we will say like this: new array list, new array list, and we'll say this is integer, and this is what? Like this, correct? Now we have, so we have initialized our adjacency list. Now what we should do, we have given edges, right? What we have given, this edges, array of array, right? This is 2D array, so we'll take a we'll take an array, right? So in this, what we will do, we'll go with I equal to what, with 0, and we'll go to its all the length, we can say, and that length is what? Is dot, we'll have the length. Yeah, we'll have our length function, and this will move to all its edges. We will move to all the edges, given edges, right? We are doing, and what we are doing here, we'll take two variables, right? At a time, one node is two node is connected with each edge, right? So each edge, how we'll get that? Either you will do like this one, or you will take like this. Either you will create for edge, right? You will say int, and today this is our edge. Either you'll do like this, either do like this or this one. Both will work, right? Both will work, this one or this one, both. So I'll take what? This one only, and we'll say the adjacency list we have. What we have? This adjacency list we have, right? And edges we have given. So we'll, each edge is connected like how if we'll talk about a variable, right? So we should take in one node, one edge we can say, each node, right? And this is what will take variable will come from what, either I or 0. Sorry, this is right, and this value will come what, this will return each edge, it will return a edge, right? And that is will say node 1 will say node A. Okay, this is our node A. And similarly if we'll talk about another one, right, another node, I will get int node B we can say, and that is our what, is at 0 I 1 we have taken I and 0, right, I and 0. So another should be what, I and it should be 1, correct? Like this we will have, got it? We will get it like this, node 1 and node 2. So either you will take two variable like this, right, or will you can do like this also. Now we have adjacency list, right? So each adjacency will have a node, right? So that is our what, you can take as a node, right? This node, okay, and this will add this would add actually, this will add what, this node B, like this, okay, node A and node B. And similarly for each node, right, for each node what we have to do, we will take its node B, node A is adjacency of node B, and node B is a node of what, A, like this, right? Like this you can say. So what we should do, either you'll, if you do want to do in the single line, you have to pass like this one, or this will come here, and if we'll take this one, the single line, right? So node B, we have a node B here, right, like this. So you will reduce your code, right? You can do like this. Now what we have, this is our for loop we have, right? We have start from what, all its edges 0 to length, right, whatever the edges given. Now we have updated, maintained our adjacency list, correct? Two things we have done here, all the variables we have initialized, and now adjacency is completed. Now what we have to do, we have to go for all its node, right, to do is it visited or not, right? So what we should do, we will start with I equal to 0, right, equal to 0, right, and then we'll say that we'll go to what, its length n, all node, and then I plus plus. We will start from the first node, right, and we'll check if is it visited. If visited node, right, visited, yeah, we'll take visited node, and then we'll take I. So if this is visited, right, if this is visited, right, so initially the visited of I is what, 0 0, means we have not visited this, right? Not equal to 0 we'll say, or equal to 0 means not visited. If not visited, then what we have to do, we have to first of all number of component we have to increase, correct? Because our component, this is our component is created now, right, one component. Now we'll do a DFS utility, we'll create on DFS utility method, and this method will take our adjacency list, right? Where is adjacency? This will take from here. We'll pass adjacency list, and then we'll pass this visited component, have we visited or not, to check there, and then we'll take a source. That source can be I. We have started from what, 0, so it will move for all the its node, right, and we will traverse each. After returning from all nodes, right, now we have, if not visited, we have visited all, right, till n nodes, right? So in the DFS it will go all the nodes from 0 to n, as you can see in the line number 18, right? After completing all the nodes, right, means we have maintained our visited, and that's why now we have our full counter we have, right? So we will return our counter, and our counter is what, 1 minute, our counter is number of components. So we have to return the number of component, right? You cannot submit here because we have to create DFS utility method, right? This one we have to create. So what we have to do, we will come to here and we'll put here and we'll say this is our source, right? This is our DFS utility method. So the return type should be what? Void, because we are not returning anything, we are updating variables, right? So we'll take a private DFS utility method, and this is our what? Starting node, right? So I'll say int starting node, or source, you can say source also. I'll take source rather than source node, right? From where we will start, source node. And we'll say starting node is what? We'll say this is visited, and this was what? We'll go take from here, this is our visited node, correct? So I'll put here. Now what we have adjacency component, right? Adjacency we have created here, this one. So we'll paste here. Okay, these things are done. Now we have, if the source is visited, right? If the source node is visited on what? Here. So what we will do? We will have we will do visited of source, right? Visited of source node is what? Now it is visited. Initially it will be, if not visited, it is 0, right? That we are checking here, line number 16, right? We are checking. If it is visited, means its value is 1, correct? Now what we should do, we will go to its all adjacency node, right? And we'll go to all adjacency list of this node, this source node, right? So let me say again, we'll take a variable, we'll say a variable. What we will do, we'll take loop and directly we will do here, we'll take int I equal to, we'll start from what? 0 index, and then we will go to I should be what? Less than what? We have adjacency list, right? Sorry, this is our adjacency list. We have adjacency list, right? And then what we will do, at the source node that we have here, source node, we'll pass our source node, right? And this source node have a list of what? Neighbors. So we will go to all its neighbor, right? So this is our neighbor size, and I plus plus all its neighbor node we will visit, right? So that's why we have started from 0 and we will go to its all neighbor node, right? Understood? What we have taken, we have first visited, then we have taken from, we will pass this agency, right? So all its source node, right? Source node we will pass here, and it has some list, right? List of neighbors. So we will move to all its neighbor. Now what we should do here, we'll make a condition and we'll check if what? If visited of what? Visited of this one, right? Start node, visited of a start node have some value, what? List of what we have, a list of neighbors we have. So we will get I. Let's see, now 5 we have, right? So 5 times this loop will check its all its neighbor, and if neighbor are not visited, then means its value is 0. Then we will go to its all nodes, right? It's all sub children, you can say, all vertices, all sub vertices in the subtree. And we'll do the same thing that we have did here of the line number 18. DFS will do for all its neighbor kid, right? Neighbor kid, how we will get it? Neighbor kid node is this one. So we'll pass our in the place of I, right? In the place of I, pass, right? This was our source, right? All source we have to pass, and all the things will remain the same. We don't need to anything. So let me recap one more time. We'll check our if there is any issue. So what we have taken first, this is the function we have given, count component, right? And we have given number of nodes, and we have given ages, right? Now we have number of component we have. Now we have number of component. Then we have taken a visited node and visited array to track the number of nodes is visited or not. And if that is done, then we have agency list, right? we will maintain our, we will initialize urgency list and we will maintain urgency like this, right? So now we have urgency data, we have, right, urgency list we have. Now what we have to visit all its node, and we will check every node at visited is 0, means we have not visited that node. Then we will do number of component will increase each time, and we'll do DFS, and we will pass its source node from where we will start. So if we'll pass the source node, right, so this will update your number of components, right? This function will increase number of component. And now if we'll talk about this DFS, we have passed source node, so this is our source node, right? And we have passing the visited urgency list. If visited at source node is we are passing that, that means we are doing what, we are making visited, and that's why we are doing one. Now what we have source node, we have a loop, for loop we have, right? And what we are doing the for loop, because we are passing the source node, right? So source node we have maintaining that this is visited. Now we have to, so after the source we have to go to all its children, like 3 is connected to 4 or not, 2 is connected with something or not, right? So it will go to its all children, right? Either there will be we have taken 5 6 7 8, right, the example. So 5 is connected with what, 6, and 5 is connected with 8, like that. So 2 times at least this node, this should go, right? And so that we can say that it is visited or not. So it will maintain our, no, all the nodes it will go. How will do that? We will pass urgency uh, at the source, and we'll do dot get, and we'll get pass the I, means all children we will move, and we will traversing for all its DFS, we are doing again for all its children, right? So I think this looks good, so I'll do compile this one. Okay, some spelling mistake looks okay. We have taken integer spelling is mistake, looks, yeah. Let me compile again. Now we have visited, like, looks like spelling mistake also. Visited at line number 27. Visited, we can visited, yeah, here. Now we have to run our code. Line number 28. What saying? DFS utility method we have taken here. Okay. I think it should work now. Visited, the spelling is mistake. Every time I'm passing the visited. Stack Overflow error. We have to try 0, okay. Stack Overflow error. So mistake we have did, right? So let me check, right? So in the DFS middle we are passing what, urgency list of integer, right? And we are passing this node, right, visited node, and then we have, so starting node we have, right? We are moving to all the visited, making 1. Now we are making I equal to 0 to urgency list, and then size, right, and I plus plus. Now we will take visited at urgency, visited urgency starting node, right, this one, then this, right, is equal to 0. Then we will do urgency list we will pass, visited pass, and the get node we will pass. So if we'll talk about the previous function, right, that be it number component we have taken, node we have taken, right? Now what we have, urgency we have here, integer of this one. Then we will move to I0 to n, and then we have DFS of this one, right? Now what we have, I equal to 0, we have I is less than, as we will go urgency list, we will I0 and I1 and I0 we will have. Now what we have, visited equal to 0, so will number of component will pass, visited will pass, and then we will do what, after that we will return, right? Okay. Something mistake I did, I'm not able to understand. What did I did wrong? If we'll talk about this one, I less than this and I plus plus. We have taken DFS 1, I0, 2 I should be less than source and size, right? We have given I plus plus, then we visited urgency list, source node and get of I, then we will DFS visited. And this should be wrong. Yeah. Not visited, we have to pass. We have to pass like this. We should pass. Yeah. So I have did this mistake, right? What we are doing, I was passing here, right? So you have to pass its all neighbor, right? So I was passing its uh, whole thing, right? I have copied from here, right? And that was my issue. We should not pass its all nodes, right? On the visited, we have to pass only our nodes, the kids node, right? And that's why I have taken urgency here. So we'll update this one. Sorry, this was only for the copying the data. And let me submit now. Oh, this is also working now. So if we'll talk about the what complexity, right? So what complexity is there, right? So what is the complexity of this one? So complexity, how many nodes we are traversing here, right? That is, given node is what we have given node, right? N. And if we have number of node is here, let's suppose here what we have given, let's n is number of edges, right? So we can say e is a number of edges, number of edges we have given, right? And how many vertices we have given? We see v is a number of vertices, right? Number of vertices, right? You will check, okay? Number of vertices we have given, and this one is given, right? So if we'll talk about the time complexity, right? So time complexity should what? O of n, right? O of e plus v, sorry, e plus v should be there, right? Time complexity. Why? Because we are building the urgency list, and it will take, see here, we are building urgency list, and it will take how many? It will take O of e operation, number of edges, right? See, we are taking number of operation here, and as we iterate over this list, right, the edge ones, we have to insert each edge into the list, right? Two times, two lists you can say. And during the DFS, traversal, right, each vertex will only be visited once, right? See here, only one time we have to visit. This is because we mark each vertex as visited as soon as we see it, and then we only visit vertices that are not marked as visited. So in this, what we will do, when we iterate over the edge list, right, we will iterate over the edge list, what will happen? We will here we are iterating, right? So what we can say, we will iterate over the edge list, right? And each vertex, each vertex I are not marked as visited, as you can see in the here. We are passing all its edges, right? And what we are doing, we are not marking as visited in all the edges, right? So we'll iterate over the edge list, each vertex, and we'll look at each edge once, right? And that's why we are saying we will have our cost is O plus E. O is E plus V, sorry. And space complexity remains same because we are building the urgency list of E, and we are keep tracking of visited vertices that have the size O of V, right? So I think you understood this one, right? So the time complexity and space will remain same. Okay. So please ping me in the comment box if you have any doubt, and please subscribe this video for the deep understanding of the programming of interview ask questions of Fang. Okay. So thank you so much for liking and sharing this video.